desktop thing sorted out. I will not be able to do the class transitions and all that stuff. So you guys will lose out on that or whatever. All right. So my name is Brian Johnson. I'm the CEO and co-founder of a local company called DivvyCloud. We've been around for just around 2 years. We're a venture-backed startup in the Arlington area. We're pitching an answer meetup and was demonstrating what we're working on, primarily focusing on a piece of our product that we'll be open sourcing, and sort of taking it out of the community, getting feedback, and trying to help us understand what a source of product is, how it would be used, because we're not open sourcing our entire product as a business. We're going to open source a piece of it. But hopefully it's a piece that everyone can use, and so use to take automation to the next level in terms of infrastructure and applications. So we will talk about the vision. So my background, primarily I worked for Electronic Arts, a large online game company for 7 years. We managed a lot of really large, massive multiplayer online games. So Star Wars, The Republic, and Warhammer Online, Dark Ages Camelot, these very large online games. During that time, we migrated from data centers into Amazon Web Services, which was a fascinating experiment with some high points and very low points. And in doing that, we really discovered that we could take automation to the next level, because for the first time, we could actually take advantage of software-defined infrastructure in a big way. So we could automate things we were not able to easily automate previously. So that's where we got our vision. Team, really not important. This particular setup, all of us came to EA except for the bottom right-hand guy who sells our software. So the cloud technology platform, our goal was to build an intelligent and automated infrastructure. So right now automation is sort of click on a button and it goes and orchestrates a bunch of things. What we want to do is take automation to where it is reactive, so that our system will respond to what it sees happening in a cloud infrastructure. Before we go any further, does anybody here utilize cloud infrastructure, private, public, any of the above? Okay, cool. Virtual infrastructure, same thing. Really basically works the same way. So the goal here was to do the automation piece, to be able to do it across multiple providers. So Amazon, Azure, Google, VMware, OpenStack. Really, as long as that API endpoint we could talk to, we wanted to be able to work with that particular infrastructure. And then ultimately, at the end of the day, what we saw when we moved into Amazon EA was our engineers who were working on server developers primarily want to have access to Amazon to spin up their own instances. This is one of the nice parts about living in the cloud, is we didn't require IT to way of accessing resources. So you can tell your engineers to spin up a server, spin up information or a limited amount in town. So during that process, we started to see that while that was a great idea, the implementation was a little rough, meaning that the engineers would spin up 30 servers and go on vacation. And so, or go to Starbucks and open up 422 of the world and go home. And so we started seeing this happen. You have two options there. You can either A, sort of put like a command and control point in between engineers and the cloud, and sort of force everyone to go to like some sort of cloud management platform or policy system that tracks everyone. We found that really challenging because it basically meant you couldn't use Amazon's API. You couldn't use auto-scaling effectively, because everything was happening outside of that central control point. So we decided to go a different route, and we developed our system. What we sort of decided was that engineers, DevOps engineers, system administrators, so on, are going to access the cloud the way we want to access the cloud. Whether that's directly through Amazon's console, or whether it's through cloud management platforms, that's that control point I was talking about, or through the API, or use auto-scaling. However it is that they're going to use it, the way they're going to use it. And quite frankly, these providers like Amazon and Azure have spent an incredible amount of money making that interface to accessing servers very easy, user-friendly, very easy to use, almost too much so in some ways. So we decided just not to get away with that. That would be counterintuitive to what it was sort of the movement. So what we chose to do is build a different type of system. The system we built is got two pieces to it. The first part is auto discovery. So what it does is continually harvest data from the different cloud providers on behalf of our customers. It pulls back all the information about the servers and their firewalls and their volumes and snapshots and everything else they have in the cloud. And it does that, and 30 seconds later, it does it again. The timing changes based on the resource type. Server, we harvest about every 30 seconds. A VPC, which is like a private network in the cloud, we do that about every 5 minutes because it doesn't change very often. But in harvesting that data in about 30 seconds, we can get an up-to-date snapshot of what you're running, regardless of where it is. An Amazon or multiple Amazon accounts or VMware environment, Amazon account, really doesn't make any difference. It will bring it all together, puts it through a unification engine we built that creates a normalized data model of infrastructure. So it allows you to server, regardless of Amazon or VMware or wherever. Brings it together, puts it in a data model, puts it in a MySQL database. So from that perspective, the DevOps engineers, Linux administrators, and so on, have a single database they can go and query to find where all their resources are, and make sure it's up to date. That's the discovery piece. What happened as a result of that was that when we were harvesting data every 30 seconds and get a piece, as a mechanism of not overloading the database, we decided we would check data to see if anything changed. So when we harvested data the first time, we again 30 seconds later, and then we compared it to. And if the server had changed in any way, say the status when running was stopping, or a security group had a new rule added to it, whatever the change might be, that's when you were in the database. This had the pleasant unintended consequence of allowing us to trigger events out of our system whenever we detect a change inside of the environment. So if the server stops, volume is attacked, whatever, we can detect that change. When that change occurs, we provide an SDK, it's a Python-based SDK, that allows our customers to essentially write custom code to be executed on these events when they occur. So this is where the automation piece comes to the next level. When you can start having the environment react to itself, when it can start managing itself on some level. So I'll give you an example of how one of the customers uses it. That sort of opening port 22 to the world thing, they allow all their engineers to have access to the Amazon console. So the engineer goes to Starbucks, opens up port 22 to the world. They've defined a policy in our system using Python that states that port 22 can never be open to the world. This should never happen. So the moment our system detects that has occurred, it immediately deletes the rule from the security group and sends the email off to the administrators, letting you know that's occurred. Yeah, hey, don't do that. Don't do that. 3306, stop doing that. So it can make changes automatically. That's pretty aggressive. We've seen other use cases where they just send an email saying, hey, this rule has been opened. We should go check it out. We've seen temporary use cases where they will allow the rule to remain open for an hour and automatically remove it after that. We've seen more business use cases where they rely on tags, which are like metadata that's associated with different virtual instances, to force people to apply a billing ID to the server. And so if the server comes online and doesn't have a billing ID, we will actually terminate the server before it hits running state. So we'll see it pending, and then we'll look and see if there's a tag on this billing ID. If the answer is no, we just terminate the server. That's pretty aggressive. The concept behind that is that if an engineer spins up a server 3 times and doesn't put a billing ID on it, and we terminate the server every single time, on the 4th time, I assure you he will put a billing ID on that system, because he will just get tired of dealing with it. Write a Python script, and that's a billing ID. That's all the CFO wants, just give him what he wants. So through that event-driven piece is what we're going to be open sourcing. The cloud management platform that we built on top of that is a UI that allows for a unified control of all the cloud resources. And that's our enterprise product. But the event-driven piece, which is just all driven through harvesting and firing off events, is what we're going to be open sourcing.
So the actual cloud stuff will be open source?
Yes. All the harvesting, the events, the plugin model, the unified data model, all of that's going to be open source. Hopefully in the next, I would say, 3 to 4 months, we're putting that up. We're actually in the process of sort of doing this right now. So we're going to do what we can to make that look pretty. Still looks big enough. We're going to find some code. You might find I have the Stash, which is a Git repository system. I have the badge for the most number of curse words in my comments. So you'll find those in there as well. The Badger badge, I think is called. So I'll stop there before we sort of go a whole lot further in and open up the questions to make sure that everyone's on the same page and sort of understand what we're talking about. Are there any questions so far?
Is it solely focused on cloud, or you know?
Today we work on OpenStack, Amazon, Azure, Google Compute, VMware, Software, Rackspace, DigitalOcean. I think there's 11 total. Yeah, our backgrounds, from being at EA, I was a director of online operations, so I oversaw the online operations. I started at EA as a Linux administrator. So my passion. Moved over to be a software engineer, and so did actually every single person, all three founders, all started in the exact same role at EA as Linux administrators, and we sort of moved around. So we have a unique background in being able to understand networking and systems and infrastructure, as well as what that might mean to an engineer, because we also were engineers as well. So in doing that, we sort of all together. I can tell you that out of all the cloud providers out there, Microsoft Azure is the one that pisses me off most. They have decided the cloud infrastructure has to be represented entirely different than everybody else. So that became the favorite thing. Any other questions so far? Before we go into the architecture?
How easy is it to add new infrastructure?
Depends on the infrastructure.
What was the question?
How easy is it to add a new infrastructure? So a new cloud provider, things like that? Yeah. So with Azure, it's pain in the ass. It took about a month. For someone like DigitalOcean, it took us, I think we did it with 6-pack in a weekend. So it's pretty quick. Once you know, the biggest challenge, the biggest part about all of it was building the harvesters correctly that pull the data down and building that data model. But once we sort of had that data model fleshed out about what infrastructure should look like, sort of siphoning everybody through that data model wasn't terribly challenging, except for Azure. And software, also Elastic. Any other questions so far? All right, we'll go on to this lovely slide. So this is the sort of the infrastructure that's built. These are the two pieces that we will not be giving out for free, which is a central REST API that you can use to query your different cloud providers, and the GUI, which is the cloud management platform. It has a lot of other things in it inside the GUI, things like an if, then this console, where you can do sort of like if server terminates and tag is, then do these things. So we can orchestrate based on events that are occurring. But the pieces we will be giving out are basically everything else. So the plugins, the event system, the notification engine, the workers, and the harvesters. So I'll cover those a little bit individually. We have the workers separated into different components. It's a very distributed system. So the harvesters are exactly what they sound like. They go out and they harvest all the data, and they pull it back, and they begin to look at it. But that's their only job. They just Python harvesters, you run as many of them as you want, put them across multiple systems, whatever you want to do. One of the things we've been experimenting with is putting them in different regions around the world, because you want to hit the API point as close as possible. The dynamic scheduler is sort of the brain of scheduling jobs, but it has no idea what the jobs are actually going to do. It just knows how to schedule them. And so the scheduler will do things, it has a little bit of intelligence in saying, if I see a system transition from running to stopping, then I know that instance is in a transitionary state. So I'm going to start harvesting that data faster so that I can try and catch it the moment it stops. We also do some other more intelligent scheduling mechanisms around different types of resources. You know, networks not being scheduled very often unless somebody makes a change in our UI, and all of a sudden we'll go out and sort of update that. So the scheduler takes care of harvesting or scheduling all the jobs when the harvesting needs to happen. It can run on a single system. We run it in a lot of our customer environment on a 4 8 system. Distributed Python processes really doesn't require a lot of power. The on-demand workers are exactly as they sound. They perform on-demand tasks. So these are jobs that like stop server, start server, make security modification, whatever it is you're doing, whatever action you're going to perform inside of that cloud provider. Those are on-demand workers. And the way they work is not to put on here is as a REST queue. So the scheduler will, for harvesting jobs, will take jobs and put them on a REST queue. And the workers will pull them off the REST queue, do their work, and submit the results to the database. The on-demand workers are the exact same thing. Whenever you issue a command, it gets put onto the queue, it gets pulled off the queue, the worker takes the request, puts it into whatever cloud provider it's been talking to, converts it into that particular format, and then issues the command. The MySQL database, pretty straightforward, it's a relational database. We are going to be spinning up an Elasticsearch database that will sit alongside this. Right now, we don't store any historical data. We use MySQL database strictly for relational database purposes, so that we can index on the different columns very easily and quickly. But that means that when we pull down data and we compare it, and then when we decide something has changed, we overwrite the data that's in the database. So we don't know what its previous state was before that. Using something like Elasticsearch, where we can store JSON blocks and version them, we'll actually be able to do some historical data. So we'll be able to show you the sort of lifespan of an entire system or an entire VPC or security group modifications that took place at the time. We've been experimenting with some really interesting things around that. A CIO approached us and asked us if we could do that and take the billing ID that I talked about, put that inside the JSON block, put that in Elasticsearch. They could actually track project over time and determine whether or not the initial sort of like costing for how much that project was going to cost turned out to be reasonably accurate or not. So sort of interesting. The event system is exactly as it sounds. It is the system that sort of detects those events and triggers and fires off events. And then the plugins, the Python-based plugins that anybody can write. So any questions about the infrastructure so far? Cool. All right. So I'll do a demo here in a second, but I don't know if you guys are going to be able to read this. Let me see if I can sort of blow this up. Whoa. So there we go. All right, so that is an example of a plugin. So what you see here is a decorator, which you can't see because I moved it up to the side. But that is a Python-based decorator. See anybody here working Python? A little bit? So a decorator is just a mechanism on top of a function that basically states that this is executed before this and allows you to do some things in Python for like registering methods. And depending on how the decorator is created, either it gets fired when the script is first executed or right before the function is executed. So it depends on how you create your decorator. The decorator in this case is just saying, okay, if an instance is created, run that function. So anytime an instance is created, regardless of where it's being created, whether it's Amazon or Azure or wherever, you want to kick off that method when it's actually your system's been created. And through that, we check the billing ID. There is no billing ID. We determine the system and then we fire off an email. So it's very simple. So these plugins can be done in very small amounts of code. Down here, ignore the function tag that's not the problem. Same basic thing. This is a little more interesting for system install. If an instance is terminated, you can go in and do some things. In this case, if the instance is terminated and has a tag on it that says environment, and the environment is production, this tags are key value pairs, then we notify the admin. So they know, but if the dev system gets terminated, we don't really care. What you typically see is a cascading effect of things that occur over time. So we also have these concepts called resource groups. They're allow you to group systems together logically. So this one down here, and this one down here, what we say is the new instance comes online and the key is the environment is production. We then put it inside of a logical concept inside of our system called a resource group. We put it in the production resource group. And that allows you then to sort of monitor that group as a set of systems or security or volumes or whatever. There's another hook point that says DivvyCloud resource group modified. So that will get triggered anytime a resource group is modified. So this begins a cascading effect. This particular code inserts that further into that resource. Another piece of code is waiting for any type of resource group gets modified to be triggered. Upon the resource group being triggered, modified, it will then do its own code. What is this actually done? So I'll use Ansible. So why would you use Ansible? Let's assume, are people here familiar with Ansible? Yes, no, Chef, Puppet, along those lines. All right. So basically, the premise we were working with Ansible was Ansible is great, but you have to know those are there. You have to sort of run manually, you got to buy an Ansible tower or whatever you choose to do there, but there's no reactive state. Using this, what we can say is any new system that comes online, we check its tag. If its tag says production, we put it in the resource group, it's production. We then have another set of code that says when the resource group production is modified, I want you to run these Ansible scripts on that system. And then when the system is terminated, let's say one of those Ansible scripts was to go update your DNS, for example, or something along those lines. When the instance is terminated, I now want to back out. I want to remove the IP address from DNS. I want to go and clean up all the things that would have been impacted by that system. Say it was a MySQL system you spun up and you had an Ansible script to put it into a cluster. When you terminate that system, you want to go zoom back out of that system and remove it from that cluster. So different things you can begin to do both on creation and termination. So that is where we'll do stop. I'll do a demo. It will break because it's a live demo and that's what we do. And we'll see if anybody has any questions after that. So let me minimize this. Wow, that's going to be really tiny. Yeah. Let's get in there. All right. So this is a log. It's called Ansible log. Before we do that, I will actually show you what that plugin looks like. Oh man, this is funky. This plugin basically does what I talked about earlier. It looks for a new instance to come online. It actually looks to see if the instance is modified. So what that means in this case is that if someone goes and changes the tag on the system, so let's say the tag was environment equals dev, and then they go and they change the tag to environment equals production, it will actually detect that tag has been changed and alter where that system is inside of our environment. So this is if the tag has been changed. We're going to come in here. We're going to look for the tag name. It does have, the tag has a key that says environment. We're going to look at that, and we're going to put it into the resource group in question, adding whatever resource group it is, dev, production, whatever it might be. So then we come down here, and we have the next one that says, well, resource group is modified, which just happens because I just put the resource in there. Then we want to trigger this functionality. This functionality basically comes through and says, for the resources, the new resources that have been added to that group, we want to come through here, check to make sure that it's an instance, because resource groups can be volumes or IP addresses or whatever cloud resource concept you want to use. If it is an instance, we pull the public IP address. It has the public IP address. We then connect it with Ansible, and we run a module ping on it in this case. So it can be anything. You could have a whole set of modules that happen here. So that's what it does. This part will not work right here because it will time out. Because I'm not going to open up a 422 to the system. You guys just have to deal with that. Okay, so this is the log file. So this is one of the workers that one of the harvesters will run here. So you'll see, see that. Let me go over here. Get off that system here. So momentarily you'll start to see. All right, so it's performing jobs. You can see maybe barely. Let me zoom in here. You can see that it detected resources, but they were unmodified, so they're unchanged, so I can't do anything about them. So when we go here, and I'm gonna, you guys want to slowly see this, but on the Amazon console, I will make change to that system, or to a system. And for the sake of this demonstration, I will bring this over here just so you can see it. We will go to that instance or not. So this is, oh my god, dev. We will go in here and we'll just change this to modify the tags. Oh my god. I cannot read all this. Tags. So right now the environment is dev. We'll change this to production. For whatever reason, we're going to choose to do that. Then we'll come back over here. And here in a moment, when it goes through and does its harvesting, it will detect that tag has changed. And presumably, it will output some information. There it goes. So that is actually running on this laptop. It detected that it changed. You see there was a modifier here, and down here it says, oh, detected instance was modified. Oh my god, there. Looking at the tags, we saw that oh my god, that had a new tag on production. We added the modified production and we moved forward. So this thing does not have a public IP address associated with it, as you can see, so it doesn't know how to connect to it. I can fix that, I believe. Think.
Yeah, you can spool it on the
Yeah, I don't know if it's in a VPC or not, so I need to see if it's. Yeah, I don't think it is. Or we may delete all of them.
Should be on that bottom one.
There we go. Let's do it from here. Associates. Okay. Oh, yeah. All right, well, anyways, I'm going to worry about it now. But the point being is that it can detect the IP address and presumably connect to the answer. So what we want to see, and what we're sort of out in the community trying to do, is talk to people about if they could build an autonomous system that could begin to manage infrastructure on behalf of DevOps, or in your system administrators. What would you do with it? And we're trying to sort of develop a number of use cases. At the answer, we'll meet up in the security world, actually. So I went back and wrote plug and do it. There's this thing called STIGs, I guess. And then through that, there's an application called Stigma, I believe is the name. It's an amazing name. And what it does is it runs on a remote system and it scores the system as to how secure that system is. 70%, 80%, 90% type deal. Based on that score, so what happens with our system that I wrote a plugin to do was, when a new system comes online, it automatically connects to that system and runs that application so that we can get a score of how secure that system is. If it falls below a certain percentage point, it just terminates the system. So this allows, sort of forces all of your systems to fall into a certain compliance, regardless of how they got spun up. If it was an old master AMI or someone just spun a random Ubuntu system that doesn't really make a difference to us. We're going to connect into it, run that, and make sure it's secure, and if it's not, we're going to terminate it. We're beginning to see that sort of policy without governance stuff a lot as well. So let me go back to wherever this is. All right. So the resources that we support today. All right, let me zoom out. Ignore this. This is silly. We support all these different mechanisms to control different resources that depends on. So changes. Some of them are sort of nameless, like I don't know why you would necessarily need to know where the public image changed, but you can when a new public image shows up. You can check to see if you're using Route 53 inside of Amazon or software as a DNS service. You can find anytime a record has been added to the DNS zone, and you can check that record to make sure that it's something you actually want to be in there. If you have a new security to modify the rule, you can check it against the whitelist to make sure that rule is allowed to be in your environment. And again, the nice part about it is what we see a lot of times, people have multiple Amazon accounts, dev, staging, and production. We can, when you trigger off that plugin that says, if security is modified, you can check to see which account that particular security came from. So if it's production, you can check against production, whitelist, or staging, and so on. Volumes, snapshots. We see we have a different type of schedule event that allows you to schedule a pass. So, for example, every midnight you want to check all your snapshots and see which one of them are older than 90 days. If they're older than 90 days, automatically move them to Glacier, or wherever it is you choose to do, or delete them. Volume types, every 60 days, scan through, or every night, you have an unattached volume, you have a bunch of unattached volumes, create snapshots of them and delete them so you can save yourself some money. Things on that.
Database instance, I assume that's
RDS.
not Redshift.
Did we look at that today? No, we support Elastic Cache, RDS. We do not support Security Service yet. We're planning to do so. We do not support Redshift yet today. When we refer to database instance in this regard, we're not necessarily referring to the data on the system, although we would love to get to that point at some point. It's mostly the status of that system. So inside of Amazon, you use RDS. When you create a MySQL system, it's exactly that. It's a MySQL instance. It sort of hides that from you, but at the end of the day, that's what it is. So we serve to like the others. But that's a good question because we're constantly looking for what ancillary services we can use, how we can use it.
There are 4 layers. Redshift.
Yeah.
All of them, very scale up and scale out. And so I don't expect one's data repository to change in size very often.
Yeah.
But you can change to a different cluster combination depending on usage.
Oh yeah, absolutely.
Well, relative to itself.
Right. Yeah, I mean that's a lot that drives this, to be honest with you, two things we found. As I said before, when you expose AWS to like your engineering department, it can become a rat's nest. Coming from sort of the upside, being a server hugging Linux admin that I was, I always, we wanted things in a very certain way, and we allowed, sort of force that standard. When you open it up to the world, things just sort of shit. So we have to see that it used to clean that up and keep it in place. And we've also seen it used because the change from a CapEx model where you're spending money to buy servers to an OpEx model where you're being metered is a very big change for companies to undergo. And so we see a lot of it being used to track costs and eliminate scale, resource, and that kind of stuff. We've seen, we've been on companies and seen $40,000 a month expense in snapshots, like hanging around doing nothing. They've been hanging on doing them for 4 months. And it's because they do a snapshot every night, and they love that, and they move on.
Really use the capability of cleaning that stuff out.
Yeah, no, they just roll with it. Untapped volumes. It's pretty nuts. The one thing I will say is really fascinating is the number, you go in an organization, and it doesn't cost any money, but you'll go in and they'll have like thousands across multiple accounts, distributors that are not associated, just like hanging around. And they don't know naming conventions to them, they're just like, whatever, right? So, and again, it's all based on this need for companies to move faster and faster and faster when they're developing, continuous integration and so on. So they just put together a script that creates security every time you deployment, creates new rules, and they're off with like hundreds of sales. Yeah, it might still die every time. I mean, I would not spend my every waking moment defending my 1-year-old daughter or biting discs if it didn't kill me on the inside every time. So let's see here. To the question earlier, we support many more of these, Linode, DigitalOcean, and Azure, HP, Helium. We support sort of an off, primarily because they're OpenStack, so we just pointed them and like, oh, it works. And so that's it, and then that's it. We are going to the hiring process. We've been, I spent the last, 5 months interviewing people, so if anybody has any questions along the interview perspective, I can answer that as well. Yeah, that's it. So is there any way that I like curiosity, there are ways that people can think about how they want to implement their infrastructure if they could do it on this level? It takes a moment sometimes to sort of get in the mindset of being like, what would I do if I could see what's changing all the time?
I'd be interested in how I with some type of workflow.
Yeah.
So the weekend into a cloud-based environment goes down. I want to be able to then kick off the workflow that allows somebody to be notified, and then given a yes or no, will allow them to reach a temporary way into that environment using separate, say, VPC and VPC queries. So I can get in there, troubleshoot it, and then turn that off. Or figure out the sort of method by which, another example, both of those shouldn't be run on at the same time, but we're only have a 1 hour.
Right.
So sort of the use case around troubleshooting.
It's actually what we're looking at doing long term is sort of taking that exact stuff and saying, all right, I know that I've got 10 web servers running in this group, and I know that I have a database over here, the master, and I know that I'm a load balancer. And I was just going to be watching all of this. Right now, we can watch things because we're actually looking back at metrics as well. So our system does have the ability right now to SSH into our node system and pull back data. We use agnostic mechanisms, sort of similar to Ansible, but
slightly different and quite a bit faster, actually. But the pull like that data, you can store it over a tree, you can make it walk into that infrastructure. So an example of this would be you have 10 web servers, you have a database, and you have your load balancer. All of a sudden, one of your web servers blasts up to 100% CPU usage. And you don't know why, but the system knows about everything that's going on. So it can see the other 9, and it goes, well, none of them are having high CPU usage. And we look at the database, they'll go, number of queries per second hasn't really gone up. Load balancer, don't really see anything there, that's keeping normal. And so as a reactive measure, it goes, you know what, I'm going to take this one system, I'm going to remove it out of the pool, I'm going to spin up a new system and take its place, and I'm going to notify the admin that you go and look at it. And then I'm going to send an email with all of the CPU, memory utilization, disk utilization data that's occurred over the last 2 hours. So they don't have to go and put up themselves. So in that, I'm also going to provide them load balancer information and database information to give them a full picture of what was happening in the environment, what happened, so that we can sort of get them further, get them to troubleshoot that problem faster.
The other thing is I usually do with something like XTTT.
Yeah. Well, we do it with our console, actually, with the UI. But we don't talk to it. We put it as not a third party. That's fantastic. Yeah, exactly. Let me get my credit card. So the service now, a few other orchestration engines, are things that we see use cases for all the time. A new server turns out, we don't necessarily use our system to do the reaction and measure, but it can be requires off the call to whatever service is going to choose to do with those guys. We've seen building scenarios with companies that run a cloud for customers. They don't have a very good way across multiple, like 30 or 40 stack clusters to detect when systems are running and when they get terminated so they can build properly. Without submitting sort of deployment, basically, anytime the system turns on or turns off, or is on the rest call to the accounting system. Says this system is not running, this system no longer running. And allows them to track off.
Another, maybe some sort of, not quite idea, but some sort of continuity of operations where since you talk to multiple public providers and private at the same time, that you could very easily trigger a workflow moving from capability of capacity cloud A to capacity cloud B and have that put your bed again and create some sort of uptime.
Absolutely. We are, so as I mentioned, we want to continue to do databases. We also are going to be getting more and more applications, so Docker containers along those lines. Again, almost everything is coming with some sort of API endpoint to it these days, so we can start to harvest data about, say, MySQL status or a Docker container that's running on a specific system. If we're aware of the Docker container and know what it does and some level and how to deploy it, we could very easily go, well, there's a problem in Amazon for some reason. We're going to deploy that Docker container. Start systems over there. The only challenge you hit so far is DNS gets locked up. So you can set load balance in your systems, but then you have to again. Yeah. So we've seen that, but you can see that going in that direction. So they'll sort of move around freely and do what they want to do.
Yeah, and I like this thinking capability too. What's interesting though, is when you stick a box, you can't necessarily be binary about it because if there's an acceptance of risk where you got a waiver for using unsupported operations to binary, and you can sort of waive that for whatever reason, then your rules have to be somewhat cognizant of that.
Yes.
It doesn't say, oh, I'm in violation.
Yeah. We also do a pullback package list on every system connected. Disk utilization, memory information package list, users that are on the system. And you can start to see that event mechanism begin to propagate to the operating system. So if a new package gets installed on a system, we know about it. And we can fire an event, and anytime the package comes up, the version of the package we can use, we can be firing an event. If a new user gets added, that's the password, we'll know about it. So it's sort of like a tripwire, but a little bit more broad, and it happens regardless of, there's no API required. So it will happen if the new system comes online, it will immediately call our work again getting monitored. So we'll see how that takes us. It should be a lot of fun. Any other thoughts?
If you look at the anti-Q, there's no project, but so in the same place for some of the.
Yeah, similar space. Yes, we looked at Manage IQ. Manage IQ is open source. It was open source, so it's still is. Open source project that was acquired by Red Hat recently. Red Hat built platforms on it. It's what the platform stuff is now. Yes, they definitely play in the same space as us. They're much more focused on sort of the management capabilities around mobile cloud management and that kind of thing, and not as much on the automation front. And they I don't know what the cloud providers support that. Last I checked, it was mostly Amazon and I think Google Compute, and of course Red Hat's.
VMware, a lot of so, but
yeah, I mean, so we got Red Hat IQ actually originally in our office.
I'm just wondering if, so what you're looking at more is, you talk about propagation automation part of that. There's an automation in there, but and I'm looking at it, it's still event-based. It's the same principle. You say something happens, fire that.
Right.
To do this, right?
Right.
So it's the same kind of idea. I'm just trying to figure out where we are. What I'm concerned a little bit about, what does people say when you are with people that you told them all the time?
Right.
They don't care, or whatever.
And all companies have, or all cloud providers have API limits. So how often can I hit their API over time? It's mostly for making sure I'm not getting lost. We have yet to hit it. I know that it's been, I think I've seen it in our development environment once, but we have not hit it. The software can be configured to how often you want the hardware data. So if for some reason you're hitting that, in the UI, we actually will show you, this is how many API, if you configure it this way, this is how many API calls an hour you will do. And that allows companies to go, well, that's 2 minutes to go all in. We have some other customers, Fortune 50 companies, working with Amazon and with Azure. They don't have it, and they can do whatever they want. So we haven't seen that be a problem as of yet. Not to say that it won't.
But the API doesn't have an event-based engine where you can say, notify me when something is set in the file.
Sure, absolutely. Yeah, like if there's, I mean, we would have to, those harvesters have to be created to, we have harvester classes. So like instance classes, security classes. We would just need to create a class and point that data back. And send it to everyone's store. Just work. Let me do this real fast so that we can.
Have you worked with the companies to do that?
Yes. One of our, to do which part? I apologize.
They send you in there when they change something that you go forward.
Oh, like a push notification type deal. We have not worked with anybody who pushes me. Yeah, it does. It really does. There's nothing more in this world that I would love just to have them push that to us, but we just haven't found a way to do that yet. I know the cloud providers are probably going to start heading down this same path. We are protected by the fact that it's a multi-cloud. So even if they enable that functionality, they only work for that provider and it's corrupt to go in the entire transaction. Let me pull this up now that I stopped. This one will certainly break. So the process manager comes allows you to do that scaling of your workers. We have a process manager that's built into it. Part of the enterprise edition allows you to say, there's like 4 or 5 systems you can use to run the workers on, and it will sort of spread them out across those systems as necessary. Let's see if it works today. No, it will not. I'll have to fix that. Maybe this. This is my development box, so you guys get to see all the next ones. Is there more tools? Am I over the console?
No, yeah. Down there, that's the console.
You. Yeah, that's not gonna work. Shame. I'm gonna do this. Cool.
So I'll show you guys the UI just so you guys can get the context, because you asked about manage IQ.
Just looking for the differentiators.
Yeah, well, I mean, so manage, I don't know how manage IQ's architecture fully works, and I don't know they allow for event-driven automation. Yeah, really the automation piece. This is what the
But not
UI looks
necessarily
like.
the same way.
Yeah, they do. So this is the UI component. You can see all the different cloud providers over here. You can see our resource groups that I talked about here, allowing you sort of group up different resources however you see fit. When we built this, we decided that IT software shouldn't have to be ugly. Although it seems like every single one I use really was. I mean, it's like they went out of their way to make it terrible looking. So we tried to make it user-friendly, fun to work with, a little bit faster, but prettier on some level. But as you can see, this is all actually, these right here are all the instances we have running our different cloud providers. Again, across multiple clouds, you can perform actions on them, so on and so forth. So if you make changes through this particular tool, we'll know who the change is. If you don't, then you won't. But this is that event-driven stuff allows us to collect changes as well. So as things change, you can go back and see on a general level, when did someone start a server, when did someone stop a server, and so on and so forth. When was the security group modified, when was the volume attached, that kind of information. Happy to go into this more, but this is not a sales demo. So we will move this out of the way. And that's it. Cool. Thank you guys.
Cool.